I think, and under this exponent thing, the book classifies this as 0 exponents and integer exponents. You might ask, what's the deal with, well, 0 exponents, that one should be the easiest one. What's the deal with 0 exponents?
Equals 1.
Yeah, anything to the 0 exponent is 1. Anything to the 0 power is 1. That should really be, if you see something to the 0 power in a problem, really, I would get rid of it right away and just write whatever's there. For example, if you see a squared b to the 0 power, please understand that that simplified is not 1. Because it's a squared times 1. Exponents only go for what's in front of it, and what's in front of it is the b, so this is really a squared times 1, which is just simply a squared, because this is 1. Now, if it was this, ladies and or gentlemen, if that whole thing was in parentheses to the 0 power, then yes, your answer to that is 1. Because it's the zeros in front of a parenthesis, the parenthesis equals 1. It doesn't get much more difficult than that. So what we really need to take some time on is negative exponents. They are not your friends. The only reason I think the book puts this in here, and really it helps you understand, is negative exponents. When is the only time really you do allow when you do have negative exponents? Somebody besides Tyler. Tyler.
Scientific notation.
Exactly. Scientific notation. When you take like 6.3 times 10 to the negative third power. That is really the only time in math it's acceptable and we use it. Now, what does that negative third power mean? We'll talk about that in just a second here. But when you talk about negative exponents with other things, we don't like them. We don't like negative exponents. And because we don't like them, we need to change them. And how do you change negative exponents? Let's say you've got this, x to the negative third power. How do I make that into something that makes more sense to me? Tyler.
Multiply by the positive 3.
Nah. Evelyn?
Negative x to the third power.
No, they don't work that way. Oh, by the way, focus on this, Brant. Negative exponents have nothing to do with whether your number is negative or positive. In other words, this. If I have 3 to the negative 2 power, my answer is not going to be negative. That negative exponent has nothing to do with if my answer is going to be negative or positive. Nothing. 0, zip, zilch. Okay. Wade is going to say?
Put it under 1.
Yeah. To change, and here's what we do. To change negative exponents to positive, you simply move from top to bottom or vice versa. This is really the fundamental rule here. So looking at this one here, what does 3 to the negative 2 power mean? Well, we don't deal with that. But what we do, what you do, if you think about this as being a fraction, it's like that. To make that a positive 2, you move that whole thing to the bottom, and it becomes 1 over 3 squared. Now that I can do. 1 over 3 squared is 1/9. Notice that's not negative 1/9, it is a positive 1/9. This negative exponent has nothing to do with whether your answer is going to be negative or positive. If it's a letter, what do you get? Well, it's just 1 over x to the third power. So, going with that thought in mind, what does this actually mean? This is actually 6.3 times, if you made this a fraction, it's 1 over 10 to the third power, which is 1 over 1,000. So really, you're multiplying 6.3 times 1 over 1,000 for 1/1000th, which means you move the decimal back 3 places. It really stands for 0.0063. because that's what 6.3 divided by 1,000 would give you, which you should know that. But that's neither here nor there because we have to do stuff that looks like this. This is the stuff that looks hard. This is the stuff that looks hard but is not. Okay, take a look at this, Parker. Focus with me here. Are you with me? Eyes open wide. So you've got this. You have m cubed p squared q to the 10th, and it's all over m to the negative 2, p to the 4th, and q to the negative 6th power. And the directions simply say to simplify this. Anybody on the thought process of this one? There, by the way, this is one of those things where you could do a bunch of different ways and get the right answer. Carter A, what would you do?
Move the m to the negative 2 often combined with m to the 3rd.
Okay, the first thing maybe you might want to do is, because we don't deal with negatives very well, is make all the negative exponents positive, which means you would take this, slide it to the top, and it becomes m to the positive 2. You would take this, slide it to the top, it becomes q to the positive 6. Then you can put those things together. What do you get if you have m to the 3rd and m squared?
M to the 5th.
Okay, on top you left, you have an m to the 5th. You still have that p squared, and then you have the q to the 10th and the q to the 6th, which is
16.
q to the 16th, because you add exponents when you multiply. But it's still now over p to the 4th. I still don't have my simplified answer. What's going to happen now, Abram?
I think that you have to divide the 2 and the 4.
Yeah, there's no division there per se. It is division, but that's not. Tell me what the answer would be. How about that?
Well, it'd be negative.
No,
Or actually,
we're not going to. By the way, you will never leave your answers in any negative form. Huh?
put it on top, right?
You don't have to put it on the top.
Yeah.
Parker?
You cross them out.
Right, you cross cancel. This has 2 p's. Oh, it has 2 p. And on the bottom there are 4 p's. So 2 of the p's cross off with 2 of the p's on the bottom, and you still have these on the bottom. And they can stay on the bottom. It's p squared on the bottom with m to the 5th, q to the 16th on top. This would be as simplified as you're going to get with that. That is as simplified as you're going to get. Do you think that's tough? Here, let me give you one. See what you come up with this. It's hard. It seems like this is a hard concept for most people to conjure up here. What if you have this? Let me give you. You tell me what you get for this. X, y to the negative 3rd, z to the 5th over y squared x squared z. Give me some sort of an answer for that. Do that out for me. We'll see if you have some sort of grasp of reality here or not. By the way, you should only end up with one of every letter. There shouldn't be 2 z's left, or 2 y's, or 2 x's. And all your exponents should be positive. Those are kind of the only 2 requirements. Grant is going to go out on the limb here. What'd you come up with, Grant?
Z to the 4th over y to the 5th x.
Z to the 4th over y to the 5th x. Z to the 4th over y to the 5th x. Well, let's check and see. I think the first thing I would do is move this y to the bottom and make it positive. So I'm taking this whole thing and just bringing it down here, y to the positive third power, so it's no longer there. I will then put that with this y here, so I get y to the fifth on the bottom, which is what you have. Up here I have 1x and I have 2 x's down there, so they're going to cross off and leave me with an x down there. And then this z crosses off with 1 of the 4 up there to leave you with z to the 4th. I concur, Mr. Brand. Anybody issues with that? Is that kind of, I don't want to like insult your intelligence. Alright, then we shall stop there. We shall stop. I've got a quiz for you.